So he's saying when a north pole of a bar magnet is made to move towards a circular coil, what happens? Current will flow in the induced current will flow in anti-clockwise direction, and a north pole is formed. And when a north pole is made to move away from the magnet, away from the coil, then a south pole is formed and a clockwise current is flowing. Induced current is clockwise. Now, how was the explanation given? He told, suppose think that, then example, he has given the example. Suppose there is a north pole of the magnet is made to move, then think that suppose a south pole is formed. Example, a south pole is formed. What will happen when a south pole is formed? This will get attracted. This automatically will get attracted and it will pass through the coil, which is violating the conservation of energy, which is violating the law of conservation of energy. Means what is happening? Even though you do not apply the force, it is attracting. It got the north pole got attracted to the south pole. It passed through that one. So that was it violated the law of conservation of energy. Similarly, suppose there is a north pole of the bar magnet which is made to move, and here we have north pole. Here again we got a north pole. What will happen? North and north is repelling. Even though you did not do anything, you did not apply any, did not even you are not even approaching the magnet towards the coil. Still, it is repelled. Again, it is violating the law of conservation of energy. So that is why come back to that is a contradiction. So that is why whatever Lenz has explained, that is correct. Yes, when a north pole of the bar magnet is made to move close to the circular coil, then current is induced in the anti-clockwise direction, and a north pole is formed. Similarly, when a north pole of the bar magnet is made to move away, then what happens? The south pole is formed in clockwise direction. Is that clear?
Yes, sir.
Okay, please copy this, then we'll go ahead.
So done.
Okay, then this is the law of conservation of energy. Right? Next one is what? Here we have conservation of energy is done. Then we have motional EMF. Okay. So we have motional EMF. We have motional EMF. Okay. In motional EMF, what will happen? Like suppose this is a magnetic field. Is this magnetic field going into the paper or out of the paper?
Into.
Yeah, this magnetic field is going into the paper, right? So we are placing a rectangular frame. Okay, we are placing a rectangular frame like this. Okay. Rectangular frame. Okay, and here. Now here, what happens? L is the length of the magnet, and x is the distance here. This is the value. Okay. Now, what happens? It is moving this frame. This is a movable frame or movable arm. This movable arm is moving with velocity v towards the other end. So what is that? PQRS. This is PQRNS. Okay, PQRS. So and this M and N is the end of the arm. Mn are the end of the arm. Now what happens when it is made to move? What happens? Current will flow in this. The current will flow in this way. That is, it moves in the anti-clockwise. The current is moving in the anti-clockwise direction. So when it is made to move, okay. So why? Because it is cutting this arm is cutting the magnetic lines of forces. When it is cutting the magnetic lines of forces, when this arm is exactly perpendicular to the magnetic field. This arm is perpendicular to the magnetic field and cutting the magnetic lines of forces. When it is cutting the magnetic lines of forces with velocity v, then what happens? Current is induced in the wire, and the current is moving in the anti-clockwise direction. Now, so what will happen here? We have RQ is equal to x, and RS is equal to L, length and width. And this, if it is constant, and here what is phi b? Phi b is said to be magnetic flux. Phi b is magnetic flux. What is the magnetic flux formula? Magnetic flux formula is phi b is equal to B dot A.
B dot A.
Cos theta. Okay. B dot A or B into A. We write here B into A cos theta. Okay. So what is the formula here? We write B is phi b because here we are taking theta is equal to how much? Theta is equal to 90 degrees. So what will happen now? Cos 90 is equal to 1. Understood now? Sorry, cos 90 is equal to 0, right?
Yes, so in the diagram you put both RS and RQ is equal to L, X.
Yeah, that is RQ is equal to X. So P, that is cos 0. Cos 0 value will become 1. Understood now? If theta is equal to
Yes.
0, cos 0 value will be 1. If the angle between the normal, if the angle between the normal to the magnetic field and the magnetic field, both are in the same direction, theta will be equal to 0. Okay. So cos 0 will become 1. So therefore, we have the formula here. Phi b is equal to what? Phi b is equal to b into Lx. Okay. Phi b is equal to b into Lx. So E is equal to x is what? X is changing with time. X is changing with time. X is changing with time. So therefore, what is that? E is equal to what? E is equal to minus d phi b by dt, which is equal to what? E is equal to minus d by dt of BLX. Here x is only changing value, minus BL is constant, dx by dt. What is dx by dt? Dx by dt is v. Okay, dx by dt is v. So here we write minus this v is equal to what? Minus dx by dt. Why minus dx? Because it is decreasing. It is the distance is decreasing. That is the reason. So we are writing here BLV. This is the formula. E is equal to induced EMF formula is what? E is equal to BLV. Okay. So yeah, that completes your derivation. Once again, see here, there is a frame, rectangular frame, which is placed between in the magnetic field perpendicular to the magnetic field. PQRS is a frame. Here PQ is a movable frame, movable wire. X is the length and L is the length and X is the length and X is the value, that is width, which is changing one. RQ is equal to X and RS is equal to L. Phi B is the magnetic flux. Phi is equal to B into A cos theta. Theta is the angle between the magnetic field and the normal to the surface. So this normal, if you take the normal, it is also going along the magnetic field. The normal to the wire is along the direction of the magnetic field. So the theta will be 0, so cos 0 is 1. So phi b is equal to what? BLX. So by x, area A is equal to Lx. So x is changing with time. So E is equal to minus d phi by dt. This came from Faraday's law of electromagnetic induction. E is equal to minus d by dt. Phi b is BLX. Just substitute in the place of phi b, substitute BLX. After that, BL is constant. Take it outside. X is only changing. So minus dx by dt. So minus dx by dt is written as velocity. So what is that? Velocity is nothing but E is equal to BL. Is that clear? This is said to be motional EMF. So motional EMF, energy consideration, quality study. Okay, energy consideration. Qualitative study. Okay, so here what is that? The formula is I is equal to what? E by R. Okay, I is equal to E by R. So here what we are writing, E is equal to what? E equal to BLV. This we studied. Induced EMF is E is equal to BLV. I is equal to what? BLV divided by R. Now, we also know that we also know that F is equal to what? What is the formula? F is equal to BIL. Okay, the force is formula is F is equal to BIL. Implies what? F is equal to B. I is what? BLV divided by R into L. So what is the formula? F is equal to what? B square L square V divided by R. F is equal to B square L square V divided by R. Now, we also know that F is equal to what? P is a power formula is P is equal to F into V. Power formula, power P is equal to F into V. So power P is equal to what? F is B square L square V divided by R into V. So P is equal to what? B square L square V square divided by R. Okay, divided by R. So here we can also write B is equal to what? P is equal to, we can write I square R also. So P is equal to what? I square R. P is equal to I square R. What is I? I is equal to, if you simplify here, B square L square V square divided by R into R square into R. So this and this will go away. P is equal to, again we get the same formula. B square L square V square by R. Okay. So this is the second way of solving. P is equal to FV and P is equal to the other way. Okay. B square L square V by R. So So we also know that what is that induced EMF E is equal to d phi v by dt. Here we know that induced EMF is equal to what? Minus d phi v by dt, or we can also write minus delta phi by delta t, minus delta phi v by delta t. And also we also know that E is equal to what? IR. V is equal to IR here, E is equal to IR. What is I? I is equal to what? A changing rate of change of rate of flow of charges. So what we are writing here? Here, because this is equation number 1 and this is equation number 2, we are equating both of them. Minus delta phi v by delta t is equal to what? Minus delta q by delta t into R. This and this will go away. Sorry. So what else is remaining now? That is equal to delta q by delta t is equal to delta q is equal to here. Delta q is equal to what? Minus delta phi v divided by R. Means what? Change in charge. Change in charge is change in flux by distance. See, once again, we have current is equal to I is equal to E by R. What is E? E is induced EMF. So E is equal to BLV. Now I is equal to what? BLV divided by R. So stop there, and then F is equal to BIL sin theta. We already know what is the force on the current carrying conductor. The formula is F is equal to BIL BLV. Now F is equal to BLV. So what did we get here? So here we got here F is equal to BLV, B into BLV by R into L. So if you multiply it, you will get this one. After that, what we get? Power P is equal to F into V. Substitute F there and V. Then what will happen? Multiply, you will get this formula. After that, we have one more formula. There are 3 formulas for power. What are they? P is equal to VI is equal to I square R equal to V square by R. So we are checking whether it is satisfying all the
Good evening, sir.
good evening. All the 3 or not. So first it satisfies the first one. The second one, we have I square R. We substitute here. We got this one. Same formula we got. Now from Faraday's law of electromagnetic induction, we got that. Second, we have E is equal to IR. Then substitute there. Then equate both of them. Then delta T will go away. Then delta Q is equal to minus delta P by R. Okay, that is the answer. Is that clear?